afternoon. This is Travis Schneider. I'm with RE Squared Robotics, and joining me today is Amanda Sgroi, Principal Research Scientist at RE Squared, the same. So Amanda, thanks for joining me this afternoon. And yeah, so maybe just to get things started, Amanda, could you tell us a little bit more about yourself, like what you do at RE Squared?
Yeah. So like you mentioned, I'm a principal research scientist at RE Squared, which really means I wear a couple of different hats. I work with business development, so I'm customer facing, looking for new business, writing proposals. I also do project management. So I help manage a couple of our programs as they relate to our autonomy efforts. And then I also do engineering work, and my specialty is computer vision and machine learning.
That's awesome. So what brought you to Pittsburgh originally? Because it seems like you've got a lot of capabilities, and there's a lot of people doing that on both the coasts. But what's so special about Pittsburgh?
Yeah, so I think there are two main things. One is Pittsburgh is a huge robotics hub right now. There's a lot going on in Robotics Row, where RE Squared is located, as well as throughout the city. And Pittsburgh's really close to my hometown. So I grew up in Johnstown, Pennsylvania, which is about an hour and a half east of here. And so I'm close to family while I get to do the thing that I really enjoy doing.
No, that's awesome. Cool. So we're obviously both recording this at home. But so when we're not being quarantined, so what are some of the things that you like to do in and around Pittsburgh?
So since I moved to Pittsburgh, I've become a pretty avid runner. I've run a couple of the Pittsburgh half marathons in the last few years. So I really enjoy the Heritage Trail, running at North Park. And then when I'm not doing that, hanging out with friends and exploring like the craft beer scene in Pittsburgh, which has really blossomed in the last few years as well.
Agreed. Agreed. That's awesome. So, like as a technologist or I guess a technology leader in the region, so what are some of like your inspirations, or like who inspires you, or do you draw inspiration from, science fiction? Like what are some of the things that really inspire you?
Sure. So my original inspiration was really during my career in undergraduate. I went to Duquesne University, and I was pulled into a research group during the fall semester of my freshman year under Dr. Stacy Levine. And it opened up my eyes to this whole different world of research. In high school, you do research papers where you're just going to the library and reading things. I had never realized that you can do research and apply it and solve a problem. So that was really where my
Right.
original inspiration for image processing and computer vision came from. And that's really what has drawn me to robotics and people in robotics who are taking their research ideas and applying them to the real world.
Mhm. Hmm. So maybe related to that too. I'm just curious too, because I know from my own perspective, I know I struggled, transitioning from high school to college, figuring out what it was that I really wanted to do. So maybe could you talk a little bit more about like what drew you into, I guess, Duquesne, and like just the general, I don't know, science, technology, and engineering for people who might be interested.
Yeah. So in high school, I always excelled at mathematics, and I knew that I wanted to do something related to mathematics. My senior year, I took a Java course, and that was my first experience programming, and I really enjoyed it. So whenever I was searching for colleges, I was applying to both math programs and computer science programs. And the great part about Duquesne was that their math and computer science department were all in one. And so it seemed like a solid path for me to get both a Bachelor of Science in mathematics and in computer science, since there was so much overlap.
Hmm.
The other great thing about that department was that so many of their faculty were doing research, even though it was a small department. Math and computer science are considered liberal arts at Duquesne. They're not actually in the
Hmm.
science school. So it was also a really interesting perspective to have on both disciplines.
Hmm, that's interesting. So then did you stay at Duquesne for graduate studies at all, or what were kind of like your next steps there?
So at the time, they didn't have just a master's in computer science, which they're actually rolling out this year. So I did switch to the University of Notre Dame, where I completed my master's and PhD. There, I was in the computer vision research group, research laboratory, And based on the funding at the time, our focus was biometrics. So I was doing face recognition and iris recognition as my focuses. And that's really where I started doing some BD activities, not knowing that they were business development. So finding my own proposals to write, my own funding, meeting with people in the government, convincing them that my ideas were good ideas to fund.
That's awesome. Cool. So then I guess so where did your interest around like artificial intelligence and like machine learning, how did that come to be? It sounded like more from the maybe more of the mathematical statistical side of things. Then you got introduced into more visual stuff. So could you talk a little bit more around that transition there?
Yeah, so I think there's a really strong relationship between computer vision and artificial intelligence machine learning right now. And so that's really evolved as I have grown through my academic and industry-based career. So for example, I was doing more image processing in undergrad, which has a little more of a mathematical foundation to it. And then I went into the computer vision world, which is more heavily I would say engineering. And there, like you mentioned, there's a lot of statistics around proving that what you're doing is a good solution. And that was during my graduate career was really my first introduction to machine learning. And that's when deep learning started to blossom as well. And so when I moved into industry, it was really, staying on top of what was state of the art and applying that to what I was doing in the industrial world. So initially that was through multispectral image processing, and then it was for ground robotics, and now it's for robotic arms.
So what are some of the things about like robotic manipulation or like robotics in general that just get you excited right now?
Yeah, so the biggest thing for me is I get to research the ways that I'm going to solve a problem. I get to solve that problem at my computer. We're stuck at home. This is a great time to do some simulation work. But then I also get to go out into the lab and see it work on the hardware. And I think that's the most exciting thing about robotics. You're not just building an application, you're building something that's interacting with the world.
Yeah, no, I agree. Yeah, that's something that really interests me the same too. It's not just a lot of theoretical ones and zeros floating across the scene. Seeing things actually move and perform meaningful tasks is always more interesting. So maybe jumping topics here for just a minute too. Now that we're talking about more specifically the field of robotics, maybe we jump into a big topic right now, and that's generally speaking autonomy. So autonomy means a lot of different things to a lot of different people, depending upon, I think, who you're talking to. So I guess generally speaking, what does autonomy mean to you?
So to me, it's really the ability for some machine to act completely independently. We talk about in the ground autonomy world, autonomous cars and different levels of autonomy there, but there are really different aspects to human intervention, and autonomy in general is acting without any human intervention at all.
Okay, cool. So yeah, because I know there was, in the earlier days of a lot of our ground robotic platforms, there was more teleoperation, but it seems like now, at least from my perspective, we seem to be getting a lot more requests for fully autonomous systems. So definitely
Definitely.
more of a trend that at least I'm seeing from my perspective. So I guess in general, like how do you see RE squared applying autonomy in its applications today?
Yeah, so I really think that we're taking the right steps towards, fully autonomous systems by having semi-autonomous systems first. It's a huge leap for some of our customers to go from a teleoperated world where humans are always in the loop and helping make the decisions all of the time to letting the machine go and do its own thing without actually having supervision. So right now, RE Squared's working on a lot of programs where, we have our perception and autonomy team, identifying objects in the world, telling the user how our robotic arms are going to manipulate them, and then getting approval to do that, and getting reassurance from the user that, hey, this is the right thing to do. With the hope that as we get our users more accustomed to autonomy, that we can move more towards those fully autonomous systems. And this also allows us to optimize and refine our algorithms to make sure we're doing the right thing.
Mm-hmm. Yeah, that's awesome. Yeah, and I think especially when I interact with a lot of our current clients or new customers, a lot of people come to RE Squared with the whole mindset of, hey, we're a robotic arm company. But I think more and more we've got this a couple of unsung heroes in the background, more from our software products that we're trying to promote around RE Squared Detect and RE Squared Intellect. Just curious if you might be able to help kind of illuminate some of the capabilities behind either of those solutions for our users the same from your perspective.
Yeah, so RE Squared built out an autonomy architecture, and part of this architecture is RE Squared Detect and RE Squared Intellect. Detect is really focused on the computer vision, the machine learning, selecting sensors for the applications that our customers are trying to provide solutions for. And that's really where the secret sauce of where is the object in the scene? Is there an object in the scene? And then how do I, approach that object? And then RE2 Intellect is really the high level artificial intelligence. So you can think of this really as a state machine of what are the steps that the system has to perform in order to complete an overall task. So for example, if there's a panel and I want to open it and do something, I have to say, press a button to open the panel, do something inside, and then close the panel. So RE2 Intellect is really the state machine that manages all of those phases.
And are those tools specific to a given application, or are those things that I can deploy kind of universally, or how does that work?
Yeah, so on the RE2 Detect side of things, it really depends on the objects that you're trying to manipulate. So those are very application specific. On RE2 Intellect, if you wanted to say do the same task, but in a different environment, maybe it's just something that you're tweaking for that application. But in general, if the applications are very diverse, then it again is specific.
Cool, awesome. No, it was really encouraging to me to see that those two products are really starting to take form. Are there other capabilities that your team is working on as well that are kind of down the pipeline? Are there other things that you're kind of eyeing? Because I would imagine there's a bunch of other software products that will be rolling out over the coming months or years, I
Yeah.
guess.
So we're definitely working on advancing our trajectory planning capabilities. It's something that we can do now, but we want to make sure that we're doing it better and staying on the cutting edge. And the other thing that we're working towards is advancing our operator control unit. So making sure our user interfaces are enjoyable for our customers to use and meaningful for their applications.
Huh, that's awesome. Cool. So, as you're kind of leading a lot of our work, specifically as it pertains to a lot of the software components within our technology, what are some of the challenges that your team's facing right now?
Um, so I would say the challenges our team is facing is really resources. There are a lot of
Yeah.
people, particularly in the Pittsburgh area, that have these type of skills, but are really interested in ground autonomy. And I would love to pull them on our team and show them how great robotic manipulation can be. But from a technical standpoint, I would say our biggest challenge is data. So I think a lot of people who are outside, say, the ground autonomy world, particularly in
Hmm.
the government space, have this challenge of there are all of these great tools for machine learning and deep learning for object detection and classification, but you have to have many contextualized samples. And that's not always available or possible to capture through government programs or small commercial efforts.
We spoke a lot about autonomy. Now I want to talk a little bit more about actually one of probably the enabling technologies behind autonomy, and that's this whole topic of artificial intelligence. Um, so I guess uh, similar to how we kicked off the discussion around autonomy, how generally would you define artificial intelligence to someone? Maybe your parents.
So, I mean, artificial intelligence is, you can really think of it as the rules that are defining some set of actions.
Mhm.
I think a lot of people talk about like, well, how do machine learning and deep learning and tools like neural nets all relate back to artificial intelligence? And you can really think of it as like the Russian nesting dolls problem. The largest doll, the largest bubble is artificial intelligence. And then inside that is machine learning. So there's a whole set of capabilities associated with that. And then inside machine learning is deep learning. And that's where things like neural nets and the fully convolutional neural networks, all of those hot topics right now, that's where those things really live.
Awesome. Cool. So what are some of your biggest pet peeves regarding the whole topic of artificial intelligence?
Um, the notion that robots are soon to take over the world. We still struggle with, robots opening doors autonomously. Not that we can't do it, but I think we really need to see some true capabilities and traversing stairs and rough terrain and manipulating complex objects before I'll deal with the fact that robots are going to take over the world.
Yeah. So maybe some of the sensationalizing of artificial intelligence and robots taking over the world. Yeah, I totally agree with that. So where do you think that potential clients or current clients of RE Squared should investigate artificial intelligence? Because from my perspective, I think a lot of people look at that as a solution, then look for problems. Whereas it seems like oftentimes it'd be more prudent for the problem set to guide us back towards artificial intelligence. I wasn't certain if you had any perspective in that matter the same.
Yeah. So I think it's sometimes a problem with buzzwords. Everyone's like, oh, are you going to use deep learning to solve this problem? And not all problems need deep learning as their solution. A lot of times, if you have, say, an object or a feature that you want to manipulate with a robotic arm, and it's very geometric, you can use classical computer vision to solve those problems, and it can be really reliable and very fast and run on very little hardware. And maybe that's a better solution for what you're actually trying to solve. So does that answer your question?
Well, I guess so. So where are those what are the application requirements that would guide me to actually needing to implement something that would leverage some degree of artificial intelligence?
Sure. I think, again, artificial intelligence is kind of this largest bubble where things live. As I mentioned with RE2 Intellect, I think that the state machine that we're using to really guide all of the phases of what a system can do, that's the highest form of artificial intelligence, is defining the rules of our system. If we're talking more on the perception side of things, the more unconstrained you make your problem, the more need there may be for artificial intelligence, machine learning, and deep learning. For example, at RE Squared, we do a lot of manipulation outdoors in uncontrolled environments. And so in those cases, you either have to have a lot of rules if you're using, say, a classical computer vision method, or you have to have a lot of data that defines all of those edge cases for your environment to use a deep learning approach.
That's awesome. So yeah, so artificial intelligence where you don't have like very specific products or very specific processes provides you a bit more flexibility in the way of manipulating components in the environment, particularly when you're outdoors, which is where we find a lot of our applications. That's awesome. So curious, do you have, given your experience, do you have any like tips or tricks that you would recommend on to people who are considering applying artificial intelligence as part of their solution, or things that they should be keeping in mind before they get started?
I think the big thing is to really ask yourself what data you have available to you. If you don't have a lot of examples of what you're trying to work with and you have to capture them yourself, maybe you take a step back into, say, classical computer vision. Or if you have a lot of data available to you and it's very constrained, maybe you can use computer vision with machine learning. If you have an extreme amount of data and you're ready to tackle those deep learning types of problems, then you have to ask yourself, what's going to be my training set? What's going to be my testing set? How am I going to make sure that I'm accurate in all cases? So I think it's really about reflecting on your data. That would be the biggest advice I would give.
Awesome. Thanks for that. Well, I certainly learned a lot today. Was there anything else that you wanted to cover?
Other than RE Squared is hiring, and if you're interested in doing computer vision and machine learning for robotic arms, please check out our careers page.
Awesome. Well, thanks for your time, Amanda. I truly appreciate it, and talk soon, I'm sure. Since 2001, RE Squared Robotics has remained committed to our mission to develop innovative technologies that make a positive impact on the world. RE Squared is a leader in the design, development, and manufacture of human-like robotic technology, solving the most challenging applications in the world. If you would like to be contacted about a robotics application, please email us at myrobots@resquared.com. That's myrobots@resquared.com. To stay up to date with the latest RE Squared news, visit our website at www.resquared.com, or you can always follow us on LinkedIn, Instagram, Facebook, and Twitter. If you'd like to see more videos like this, or videos featuring actual RE Squared robots, please subscribe to this channel on YouTube.